In this video, we'll be solving a problem that involves similar polygons. If two angles of one triangle are equal to two angles of another triangle, then the triangles are similar. And if two polygons are similar, then the measures of the corresponding angles are equal and the measures of the lengths of the corresponding sides are proportional. Now this is not a misprint. It says two polygons are similar if and only if. This is a way to say that our statement goes in reverse as well. In other words, if the right side is true, then the left side is true. If two polygons are similar. And if the left side is true, then the right side is true. So if we have similar polygons, then we can set up a proportion to find missing lengths of the corresponding sides. Now the problem that we'll be doing is to find x, y, and z and show work to support your answer. It looks like we have right triangles. On the left right triangle, I have legs that measure x and y and a hypotenuse that measures 7. And on the right triangle, I have a hypotenuse that measures 10 and legs that measure 8 and z. So we can immediately, since we know that we have a right triangle, we can immediately find the length of z using the Pythagorean theorem. Now if you're familiar with your Pythagorean triples, since 10 is my hypotenuse, I can use the triple 3, 4, 5 and double each of those dimensions to get 6, 8, 10 for my dimensions on this triangle. But let's go ahead and use my Pythagorean theorem just in case we don't remember that triple. The sum of the squares of the legs of the right triangle, 8 squared plus z squared, and that's going to be equal to the square of the hypotenuse, which is 10 squared. 8 squared is 64. 10 squared is 100. Can subtract 64 from both sides. These will cancel, and I have z squared is equal to 36. Square root both sides, and z is equal to, now algebraically I should say plus or minus 6, but since this is the length of a side, I'll just say 6. So we know then that z is 6. So if z is 6, now let's see if we have similar triangles. We know that we have these angles congruent because they're both right angles. And we know that this angle is equal to this angle because vertical angles are congruent. So since I have two angles of this left side congruent to two angles of this right side, then my triangles are similar. So let's set up our proportions. We'll go with side x first here. It's the side across from the single notched angle. So we can say that x is in proportion to z, which is 6. And then let's do the hypotenuse next. Across from the right angle is 7 on the left-hand triangle. And then across from the right angle on the right-hand triangle is 10. And then let's see, y is across from the angle that's not marked. and across from the angle that's not marked on this side is going to be 8. So now I can use my two left ratios. X is to 6 as 7 is to 10, and do cross products to find the value for x. So x times 10, and then 6 times 7. Divide both sides by 10, and x is equal to 42 over 10, which is 21 over 5. Now let's use our two right ratios here to set up a proportion to solve for y. Again, we can do cross products, and we have 10 times y is equal to 7 times 8, which is 56. Divide both sides by 10. Our 10's cancel, and y is equal to 28 fifths.